I want to demonstrate middle of the linked list on Leetcode. Given a non-empty singly linked list with a head node named head, return a middle node of the linked list. If there are two middle nodes, return the second middle node. So we have an array here that acts as a linked list. We have the value 1, 2, and then they each have a pointer pointing to the next value. That's how a linked list works. Or that's how a singly linked list works, I should say. So the output is node 3 from this list because 3 is the middle node. In this linked list, we have two middle nodes right here, 3 and 4. So it says if there are two middle nodes, return the second middle node. So we return 4, and it says node 4 as the output. And then we have a boundary here. The number of nodes in the given list will be between 1 and 100. So that's basically the parameter. The first thing I'm going to do is make a constant variable named array and equal that to an empty array. And then we're going to return that array at the end of the function. And so I'm going to use recursion on this because I want to demonstrate recursion. I feel like I need to demonstrate it in my videos because I haven't done it yet. So it's going to be a nested function, and that nested function is what gets recursed. And I'm going to name that function traverse. And this function is going to take in a node parameter. I'm going to create my base case for the recursive function. Every recursive function needs a base case. So it's not iterative. So it's going to check every value in the array until the array is empty, until it doesn't have a value to check anymore. So my base case is going to be if this node parameter equals null, that's it. We're going to return. It's going to be the end. And so for every number in the array that it checks, we're going to push that number into the array. So array.push node. And then this is where the recursion takes place. We're going to call the function again. We're going to call the function traverse. We're going to call the nested function traverse again and put the node.next in as the parameter. Node.next is the next value in the linked list. And then in order to use this function, we're going to call it again right below, put the head in there. And so that'll keep recursively happening until it gets empty. And then we're going to access the array. So we're going to access the array here, and we're going to find the middle value inside the array. So we're going to take the whole length of it and divide it by 2. So array.length, going to access, and then do array.length and divide that by 2 because we need order of operations. Let's try running that. Okay. I'm going to put a JavaScript function math.ceil in front of our array.length divided by 2. And we need to access the last value in the linked list. So we add a -1 there. Let's run this and see if this works. And it did. Let's submit it. It did not work. So let's do math.ceil in front of that. Wrap those. Try again. And that works. This has an O of n runtime complexity, a linear runtime complexity, because we're going through each value in the array until it's empty. So it's a linear